Section 1.4, we're going to be writing equations of lines. So a few of the things we're going to do is find slopes of lines, and that includes parallel and perpendicular lines. We're going to be able to graph lines using the calculator and also without the calculator, write equations of lines and write equations of lines including the horizontal and vertical lines. Okay, so here's an example, and this is actually Algebra 1 stuff, so it should be pretty easy. You're given 2 points, and we're told that the line passes through these 2 points, and what we want to do is find the slope of that line. So to find the slope of a line, remember it's the change in y over the change in x. So to find the change in y, we can say 2 minus 1, and then to find the change in x, it would be negative 1 minus 4. And you need to make sure you go the same direction here. So change in y, I said 2 minus 1. So then when I go to do the x's, I need to go the same direction here as I did. And that's going to give me 1 over negative 5. So the slope of this line is negative 1/5. Okay. And here in this example, what we're doing is finding the slope of each of these lines that are shown. So let's do the two that are easy first. C is this vertical line that we have here. So we've got A, B, C, and D. Although I call it the easy line, is something that a lot of people usually mess up on. So when we talk about a vertical line, so that's line C, and that is here, the slope of that line is undefined. And then we've got this horizontal line here, D. The slope of that line is 0. Be very careful with those. If it has a slope that is undefined, like it does in B, then the equation for that is going to be x equal to some number. And if it has a 0 slope, then the equation of that line is going to be not x equals some number, but y equals some number. Okay? All right, and then for A and B, so let's look at A. Maybe choose a couple points on the line. Let's erase what I have here. So for A, C, looks like it goes through this point and through this point. So, so I could have said that one. So it looks like it's rising 1, up 1 over 1 is what it's doing. So change in x divided by change in y. So in this case, this is positive. It's increasing from left to right. So we could say that the slope is 1 in that case. Then when we go to B, it looks like what's happening here is maybe it passes through, let's find a couple of points it passes through that point and passes through that point. So it looks like we are going down 2 and right 3. So, and we notice it is a negative slope. So we've got a slope of negative 2/3 there. Okay, here we're going to sketch the graph of this equation and confirm that sketch with a calculator. So if you're going to sketch the graph of an equation, you can start out with the equation as it is, but most people, most of you probably like to go ahead and get this in slope-intercept form, which is fine. So you can do that, or you can plug in zeros and find the x and y intercepts. So there's several different methods, but since we're going to graph it in the calculator, let's go ahead and solve for y. So when I do that, I'm going to get negative 4y is equal to negative 3x plus 6. I'm going to divide everything by negative 4. These cancel, and I get y is equal to 3/4 x minus 3/2. Okay, so not fun to graph this one because we have a y-intercept of negative 3/2. So it might be best to go back and try to graph. Plotting, negative 1.5 wouldn't be great, but we could certainly do it. So we might want to just try to use, if I plug in 0 for x, then into this equation here, if I plug in 0 for x, then again, I'm going to get a fraction. So that's going to give me negative 3/2. So still sort of not great. So let's plot that one, and then if I plug in 0 for y, I'm going to get x is equal to 2. So if we plot those 2 points, the point 2, 0, and the point 0, -3/2 is here. And it looks like the equation of our line is going to be, or the graph of our line is going to look something like this. Okay, not great here. Yours should be a little better. The key here is that when I ask you to graph, it shouldn't say sketch, first of all. That's my fault. But when I ask you to graph a line, I expect to see points plotted. Okay, so I really want to see at least 2, probably more like 4 points plotted when you graph a line. If we check this on our calculator, then we had y equals 3/4 x minus 3/2. So let's try this. Go to our y equals. Okay, and we're going to graph that. And you see it looks very similar to the graph we have. So we've confirmed it with our calculator. You could also look at the t-table on that and notice that we have the same values. All right. The next thing we have is an application problem. And we've gotten an office that's going to buy a new color copier for $8,200, and then 4 years later, it's worth $2,320. So we're going to assume that it depreciates linearly, and we're going to write an equation for that and represent the value as a function of years. So when we're doing that, it's actually not that bad. What you need to think of is you need to think of the information that you're given as sets of ordered pairs. So when it was age 0, we paid this much for it. So that's your set of ordered pairs. And then 4 years later, it was only worth $2,320. Okay, so there's your ordered pairs. And now that we have that, we can find our slope. We can also find our y-intercept, or we can just write the equation for this. So to find my slope, I'm going to say 8,200 minus 2,320 divided by 0 minus 4. And that's going to give me negative 1,470. So that's going to be my slope. And then once I have that, I know that I have my y-intercept already here because the x value is 0. So the equation of my line is y equals negative 1,470 x plus 8,200. Okay, so there's the equation of the line, and then we're going to find its value 3 years after it was purchased. So that just means taking 3 and plugging it into your equation. So let's say we call it a function f of x equals negative. And it did ask us to write it as a function, so we should use that function notation. So f of 3 is going to be and that means 3 years later, that is going to be worth $3,790. And if you think about it, that makes sense. It should be worth a little more than what it was worth after 4 years, and definitely less than the 8,200. Okay, and then of course we have to graph that equation. You know, for this, it's probably going to be best to use the information and graph this on your calculator. What you know when you're graphing this is you know that your y-intercept is at 8,200. Okay, so and again, it should be a graph and not a sketch, so you should be able to do this on graph paper. So that, and you know that it's going to be depreciating. And of course, the only part of this graph that's going to make sense is what falls in this first quadrant, because it's never going to have a negative value. So we'd probably want to figure out what this point is right here, and then graph using that information, which is what part D asks us. So let's slip on over to that and find out what we would get here. So we want to find out how many years before the system is worthless. So that means it's worth 0. So we would say set 0. That's our that's our output value, and we don't know our x value. That's what we're trying to find, and we solve this equation. So and that's going to give us that x is, and it doesn't come out so nice, but x is approximately 5.6 years. Okay, so we have the ordered pair, approximately 5.6, and it's worth 0. So if we go back to our graph now, we know that that is about 5.6, and that would give you the graph of that equation. And you could use that to help you come up with a good graph on your using your calculator, because you would have to go back and set your x and y axis to make sense there. Okay, here we have example 6, and on this example we're going to write the equation of a line that passes through these 2 points, and we're going to write it in slope-intercept form. We're going to start out by finding the slope of this line, and the slope is going to be, y minus y over x minus, which changes to a plus because we have minus a negative, and so we're going to get a slope of -3 here. And then once we have that, we want it in point slope form, so that's very easy. Just choose one of the 2 points. It doesn't matter which one. Let's say I choose this one. And the point slope form is y minus y1 equals the slope times x minus x1. The values that are going to get replaced are y1, slope, and x1. So we just replace those. So we give us y minus, choose one of the 2 points. We chose the first one. Our y value is 5. My slope we know is -3. X minus, and our x1 value in that equation was -2, so it changes that to a plus, and we get this. And this is the slope-intercept form of that equation. All right. In this one, we're going to write the equation for the line that passes through the point 1, -6, and it has a slope of 2. So this one is super easy. It doesn't tell you, it does actually tell you that you want it in slope-intercept form. So given this information, we can start out in point slope form and just change that. So y minus, the y value is -6, so we're going to take y plus 6 equals our slope, which is given to us as 2. And then x minus our x value is 1. So we end up with y is equal to 2x minus 2 minus that 6 that I move over. And so the slope-intercept form of this equation is y equals 2x minus 8. All right. In this example, we've got a line here, 5x minus 4y plus 8 equals 0. And we're going to find the equation of the lines through the point -4, 2 that are parallel to that, and then that are perpendicular to that. So if you're talking about lines that are parallel and perpendicular and you have a point, the other thing that you need is the slope. So working with that line that we're given, we're going to first of all go and find the slope. So let's do this and go ahead and move that -8 over. Then of course we want to move over the x. Let's divide everything by that -4. And we are going to end up with 5/4 x plus 2. So we have the important thing here is that our slope is 5/4, and that's what we're going to be using. So if it's parallel, then it's going to have the same slope as this line that we're talking to, because of 2 lines. But if a line is perpendicular to it, the slope is going to be the negative reciprocal. So what that means is you take the fraction, flip it over, and then you change the sign. This one was positive, so this one's going to be negative. All right, so we have that information. We know that they both pass through this point, so now it's just a matter of writing the equation, and it doesn't tell us a specific form. So I can say point slope is the easiest. Y minus, my y value is 2 equals, my slope is 5/4, and then x minus my -4 is going to be x plus 4. So that would be an answer there. And then when we're talking about perpendicular, same process, y minus 2 equals, this time it's not 5/4, it's -4/5, and then it's x plus 4. Okay, so the only thing that's changing between those two, since they pass through the same point, is the slope. All right, and now we're going to find the equation of the line passing between these 2 points. Just a couple more problems here. So if you look at this, your process as we did earlier is to find the slope, and then once you have the slope, it doesn't tell you a specific, you can plug right into the slope intercept. But what you want to look for first is, do you have a vertical or horizontal line? And here you notice both of these are -5. So if both of those are -5, then that just means that's your x value, it's -5. They're both the same. The equation of your line is this. That would be a vertical line, and your slope would actually be undefined there. Okay, and in this next problem, we're going to find the equation of the line with a slope of 0 and it's passing through the point 4, -8. Well, if the slope is 0, then what we have is a horizontal line. And it's passing through the point 4, -8. So what's staying the same here is if it's a horizontal line, what's staying the same every time is the height. Okay, so that's 4, -8. This point might be 5, -8. Okay, and then 6, -8, and 7, -8, and so on. So again, you realize that those are the same, so the equation of this line is this. Okay. And that's all I have for this section, and we'll pick up with section 1.5 next.